The inverter is a printed circuit board that sits in the top of the outdoor unit. So this heat pump has an outdoor unit and an indoor unit, and the problem lay here. So let me get into the details. So it's a V14 S1 unit, which basically has a heat output of 13.5 kilowatts based on a input power of 3 kilowatts. It's made by Tosot. They're a Chinese. They're a brand of the Chinese Gree company. It's used in North America. The Gree equivalent of this, from what I could tell, is this model number. And I bought it in October of 2017, and it worked very, very well for me for 5 years. But it stopped in May of 22, and when it went out, it tripped everything in the house and switched the breakers back on, but now it was displaying an error that there was communication between the outdoor and the indoor unit. So checked the cable, no problems. So the next step was to, investigate the inverter on the outside and what was going wrong. So the inverter, like I say, is in the top of the outdoor unit, and here's some detail on it. The version you can see there of the board, and so we start out with this MCU microcontroller. U14 is worth noting. There's this Nixie tube display, and there's a daughter board on it, and the board itself is. Let me see. There's the CN66 connection to the indoor unit. You've got a connection to outdoor fans here on this side, and that whole section of the board is dedicated to the outdoor fans. There's a filter board here, which is a separate board. There's a single phase power input. And then there's the inverter itself. You've got the three-phase AC compressor output, so that's variable frequency, and that's all done through pulse width modulation through the integrated power module. And there's a large inductor off the board, which is connected through this yellow and white wires. There's a power factor correction module under here to control the power factor effect it has on the grid. And then there's this 15 volt test connection point. And when I started looking into it in detail, here's the schematic from the user manual. The layout is pretty logical. You've got the mains coming into the filter board and then feeding into the main board, back out through the inductor for the power factor correction, and then, depending on the electronics, the three-phase output to the compressor. And you've got the power to the two DC motors, the fan motors, and then you've got various different connections to sensors and valves and temperature sensors here again, and then you've got the CN66, which is the connection to the indoor unit. So started looking at, what can I do with this? My inverter board, when I looked at it, it kept rebooting on about a minute cycle. It was showing up a comms error, E6, and then a H5, telling me there was an IPU failure. And there was a clicking noise coming from the valves. Wasn't clear which one. There was no voltage on the output side. So I disconnected the compressor and the inductor, looked for a short circuit there, no problems there, and really everything was pointing back to the inverter failure. Right, so looked to get a replacement from my dealer. He got back to Gree directly in China. No part available. Forget it. Even though this unit is less than 5 years old. The Tosot warranty on their website talks about 10 years parts and labor, but it's worthless. It's not clear that Tosot was ever marketed in Europe, but even still, you would think Gree would stand by it in China. Tosot themselves wouldn't even respond to an email, so nothing to be got there. I looked at repair options. No repair shop would take it on. I tried myself, but it's considered an industrial unit, and they weren't going to touch it. And the dealer also tried on various different people in the trade, and they thought the MCU looked like a problem. They didn't have any details of this board or any idea how to fix it. So really, it kind of dawned on me that I was on my own with this. So started looking into it in a little bit more detail. I went online, no direct replacements, just the original part number, and no match for anything like this in anywhere on the web at that time. The board model, I mean, what I could go on maybe was the board model. I went on and I found a few matches for this on AliExpress and Alibaba from China, and nowhere else. And the only model number they had available was this 30226032, and that was coming in around 800 plus delivery from China. So that wasn't a very satisfactory solution. I mean, even if the board was a direct match, it was still, a bit of a not certain that it would be good. And then, once you look at the photographs in more detail, there are clear differences, between this model and my own board. So basically, the model looks great and it looks pretty similar, and the version matches, and that's a good start. But when you start looking into it, sensor 3 is blank. CN66, the indoor-outdoor connection, is blank. There's nothing on it. And there's a totally different fan motor connection. There's several components missing here, and the fan motor components are missing as well. And this is a different size capacitor. So, there's lots to think about there. So this left me with, what am I going to do? The heat pump has to be fixed. I'm not throwing it out after 5 years. I expected to last 10 years at least. But my own board looks like it's dead, right? So if I bought a replacement, it could act as a donor or a reference board, that might be similar. And if I got it, it might be possible to use a different motor with it if I needed to. All the advertised boards on AliExpress used this stock photograph. They showed the 1.4 board. So eventually I jumped in and bought one on AliExpress. And then the guy sent me the actual photo, and it was a V1.2 board. So that was no good. I wanted a 1.4. So I cancelled the sale, right? So then I tried again, and I got the photo in advance from the guy, and you can see here it's a 1.4 board, and the guy even included a picture of his foot, so I can come get him if I need to. And it's covered in dust. I don't know why you would have it covered in dust, but it was. And yeah, again, doesn't fill me with confidence, but was quickly running out of options at this stage. Bought it on FedEx or ship it through FedEx, and 4 weeks to wait for it to arrive. So, in the meantime, I went back to my own board while I was waiting, took it out, and why did it fail, right? So basically, looked at the underside of it, and it was clear that you can see a scorch mark there. There was a short circuit on the integrated power module. Okay, so that was the thing that was giving me the H5 error. There's also this other unit, power factor correction module, another integrated chip. And so basically, it was kind of clear to me that there was some insect walked in and short circuited the thing. When this is upside down, it's sitting, maybe 10 millimeters above a heatsink. This copper plate actually is actually down on the heatsink with heat transfer paste. So, there's a pretty small gap. This is just a close up of the pins that were damaged. You can see they're scorched there, and you can see the heatsink here has scorch marks on it as well, where the damage was done. So, like the insect was well fried at this stage. So, the question came then, maybe I can reclaim my old board, just replace the integrated power module, and it should be fine, right? But there's also this U14 on here, which looks a bit suspicious. This top of it seems to be melted and bubbled up. But 2 years ago, I looked in at this just for curiosity, and I saw this as well, and I think it was actually working in that state. So, who knows whether that's a problem or not. Um, so my board was rebooting. I started plugging things out just for experimentation and back in again until I found that when I had the EKV valve plugged out, I should say, the board did not continuously reboot, and it continuously displayed the H5 error on the Nixie tube, right? So H5 is IPM defective error code. So basically, the board itself is not brain dead. It's and all errors are pointing at the IPM. So the IPM is pretty complex beast, as you saw, with several pins. I think 30 pins or something like this. Impossible to desolder it. So I just cut the pins and then desoldered each individual pin individually. And the chip itself is this Fairchild module that there's lots of information about on the web. It's an integrated gate bipolar transistor, and basically it's the thing that's doing the pulse width modulation. It's the fan motor, or it's the compressor control giving three-phase output with pulse width modulation. So I decided I'd buy one. The only place I could get it is from Hong Kong. It was discontinued, and some people had it left in stock. But there was a 6-week delivery wait for that. For I actually bought two of these to have a spare in case I had any problem, and the two of them together, including delivery, for about €100. Uh, in the meantime, while I was waiting for that to arrive, my replacement board arrived from China. So, like I said, maybe it would act as a donor, or maybe it would act as a reference board or something if I try and get the IPM fixed. So it arrived, and as you can see, the part number, the version number on it is 1.2. The guy had sent me a 1.2 board, even though he'd sent me previously a photo of a 1.4 board. So back and forth on AliExpress, try and get him to send the original one in the photograph. No chance. Guy said board is working. That's it. So got to AliExpress dispute resolution. They agreed he was at fault. They gave me two options. So I could send it back for a full refund, or else I could take a 10% discount and call it quits. So I said, look, let me go for the full refund option. But I don't know what happened it. I chose it and nothing happened. They seem to have ignored it. And again, 2 days later, I got the same two options again. So this time I took the 10% refund and I closed the dispute because I figured a bird in the hand is worth two in the bush. I'd have something and I wasn't going to have to wait 4 weeks again. Who knows whether the thing will work at all. So I considered my own board, and before I started pulling it apart and taking things off it, I thought, hang on, let's just try and fix the IPM, right? So desoldered, all the cut-off pins from the IPM, board was clean, put on the new IPM when it arrived, switched it on, and I still get H5 again, right? Still IPM defective. So I did another literature search back through everything again, and there's all these reasons that IPM error can come up, IPM defective, and I eliminated all of those, except this pointed that there could be an abnormal PFC module. So I went through all the diagnostics, 15 volt of the main board is stable. Yes, it was, so everything was kind of pointing me, maybe it's the PFC module. So I started looking at the PFC module, and there's I found a couple of oddities with it. I was comparing the resistance across pins when it was switched off, and I was comparing them to the replacement board, and it was showing short circuit on a couple of pins. So I decided, let's take it out, let's get a replacement. Again, it's a Fairchild module. It was out of stock everywhere, but I got it on Radionics. They had a couple of them in stock, and it was pretty quick to get it. You can see there's a lot of these pins really were not connected. This is a fairly standard enclosure for a lot of different modules, power modules that Fairchild do. So you have to be careful to get the right module. So it's a pretty straightforward device once you put it in, but still I get the IPM defective error. So at this stage, I gave up on my own board. I tested every line in and line out of it statically, compared them to the replacement board. Everything looked exactly the same. I even plugged both of them in, and checked all the line voltages, and even the fault out sensor on the PFC and on the IPM, and they all made sense too. They all matched, but still no dice. So that was the end of my own board, and now it becomes a donor board. So I start looking at the replacement board, and there's, I wanted to see what it did when I powered it on, and the first thing I got when I powered it on was the E6 error, right? So this is unable to communicate with the indoor unit. So there was no pin header on CN66, so I added one, but still no dice. So tried several things, and eventually I took the daughter board off my own old one and put it onto the new board, and suddenly fixed the E6 error, could communicate with the indoor unit. So that was good news. Next up, I got C5 capacity dip error. So basically, there's this little jumper that you put in here, and 07 is for the 14 kilowatt unit, and transferred that over, and it got rid of the C5 error. So after that, I got an F5 error saying there was a problem with the suction sensor, and like at this stage, I didn't know if if sensors had been blown or anything like this. So I put a pin header in place where T sensor 3 should be, because that had been missing on the replacement board. Still didn't do anything. Then I figured out that the suction sensor actually was on T sensor 2. And for some reason, the socket here, even though it's exactly the same shape, on the replacement board, it's like 6 millimeters deeper. And so the plug wasn't sitting down in it properly. So trimmed it off with a knife, and adjusted its height. So basically that error is gone, right? So that left me with the next problem, which was fans. Okay, so the system starts up and it stops with an EF, an outdoor fan error. Now I was expecting this because the connectors are missing. Checked all the voltages, and these extraneous fan connections basically were showing no power on them. Okay, and these guys were showing the correct voltages. This was giving out pin 1 315 volts DC, and this was ground. Okay, so of the missing fan connections, pin 4 is 15 volt. Pin 5 is the control signal, and pin 6 is the feedback signal. And it's the lack of that feedback signal, basically, that causes the EF error code. Okay, so, and what I found actually is that it's only the feedback from DC motor 1 that's used, just by following the tracks on the board. I found this out. Okay, so, but there are still the problem of missing components, and how do I connect my fans, right? So basically, the missing components are on this side. You've got header 1 and header 2 are obviously missing. You've got a different capacitor size both sides. You've got this capacitor here, C104, diode D14 and D1, another capacitor here, and then importantly, these optocouplers, I should say, yeah, U18 and U12, right? So basically, what they're doing is they're connecting this isolated board section. The strong white line here is showing that the fan control circuit is in here, and this operates at a totally different voltage than the rest of the board. So there's optical isolators connecting the signal from each side to the other. Uh, Other things that we're missing is these surface mount resistors. Um, 108, 104, and R15. There were capacitors here as well. There's another set of resistors up here, and then there's this resistor outside the isolation area, and there's another capacitor there, C124, and that capacitor was in place, but the resistor was missing. So I started looking at, this whole motor drive section, and it's optically isolated from the rest of the inverter. The optocouplers, so the layout of them is U18 is feeding the signal into this section. That's the command signal to turn on the fan, and then 12 is the output signal telling it that the fan is running. These optocouplers are sensitive to temperatures, and so you can desoldering them, you're going to overheat them. So I didn't reuse the old ones, and I looked and sourced new ones. So for the pins, you have to be aware as well that pin 2 is missing, but this pin 3 is actually a bit of a danger because it's minus 120 volt compared to real ground. So the whole circuit runs at minus 120 volts, and then the 315 is so many volts above zero, real ground. The control signal is on pin 5 and feedback is on pin 6. So I got some stuff off Farnell, so the pin headers. I just manually punched out pin 2, but otherwise they were exactly an exact match. This capacitor, the big one, I desoldered off the old board, and then I got new surface mount capacitors and ordinary capacitors off Farnell as well, and a new diode for D1. I reused the old one. I couldn't find. I wasn't sure which replacement it was, and then I replaced the optocouplers as well. So that was an isocom unit, and I got surface mount resistors. I basically desoldered them and found out the resistance from the old board. And I soldered everything in, but I'm still getting the EF error, external fan error, right? So there's several possible reasons for this, right? So obviously I might have done something wrong. The signal might not be coming in, the signal might not be going out, there might be something wrong with the fans, who knows. So eventually I narrowed it down with some experimentation. What I did was I temporarily held a resistor across the output terminals of OC18 and the fans ran. Okay, so basically this tells me that it was the input signal was a problem and that all my component replacement had worked properly. So, with this varying the resistance on that controls the fan speed, and that sorted my EF error. And at this point, my heat pump was working again, right? I had a solution. So, just to conclude on this, there's something wrong with the input signal to OC18 or U18, actually, I think it is. And what it's telling me is that the board, the circuit that's supplying the signal has something different with it, and it's not energizing the optocoupler like it should. I checked everything, could not find any component missing. I didn't perform a live test to try and diagnose. Really, at this stage, I had too much to lose by poking around with my multimeter in a live running system. And I soldered the resistor in place, on the optocoupler and left it for actually a couple of months, because now my heat pump was working and it was generating heat again. Okay, what I meant is that when the inverter is powered on at all, the fan runs. So basically, I had to switch it off at the mains to fully shut the fans down. That persisted for a while. But eventually, yeah. So actually, I wanted to just describe a little bit about the optocoupler. So it's basically simply a LED light emitting diode and a phototransistor in the one housing, right? And the LED brightness is proportional to the input current across this, okay? And the output current is driven by the resistance. And so when I added the resistor across here, it allowed current to flow in the circuit, and that turned the fans on. And the one thing to look out for here is this black dot, which is always pin 1 when you're locating this thing. Um, so what I wanted to do is be able to switch on the outdoor fans then, in some kind of a mode that could be controlled by the system, and not have to switch it on and off at the mains. So I had no on signal that I could trust on the outdoor board. So I looked at the indoor unit and thought, hang on, there's the water pump, right, is being switched on whenever the system is about to run, and there is a controller there that switches that on. And what I found is that its timing was exactly what the fan motor needed. So the problem is how do I get that signal out to my outdoor unit? So I wanted to bring the 230 volt AC down to a DC signal or DC power. So I got an old Nokia phone charger, which was giving out 5 volts DC at 350 milliamps. And using the old formula V over I is equal to R, I figured if I wanted like 5 milliamps, I'd need something like a 1K resistor. So I had two 470 ohm resistors and just connected them in series to bring it down to 5 milliamp. And when I was installing the unit originally, I left a spare Cat5 cable in the conduit out to the outdoor unit, and now I got to use it. So I mounted a small breadboard, in the outdoor unit. There's my Nokia charger. So you can see this is connected to the client pump's water pump connection here. It's powering this, and this is sending the voltage outdoor. Here's my outdoor unit, and I just made up a small breadboard there, connected the pins across to that side of the optocoupler, and then this is connected back onto the board. I just put a pin header because I didn't want to be messing around with soldering on the board anymore. And this actually fits into the header of the extraneous connectors. There's no voltage going through them, and besides, the insulated side of the breadboard is pointing back to the pins. And there's my fan motor signal going in. Now, the one thing to say about this is that the fan motors themselves are variable speed, but now it runs only at one speed, and that's driven by these resistors. And I could put a pot in there, but still it would be a manual speed control. The thing about running the motors on this speed is they use slightly more energy than it should. For instance, when the air temperature is high outside, the fan doesn't need to run as fast. You don't need to pump as much air through. But this is a small complaint. I mean, the fan motors really are 120 watt motors. So the difference between them running at half speed and full speed really for two of them is still only like 120 watts. So that's not that big a problem. Let's switch to on, and we're expecting our fans to come on any minute. And there we go. And she's up and running. And there it is running. No error. Hot water. Good to go. And so my heat pump is back running again. And just to give some conclusions on the whole process and the whole experience, I saved my heat pump, and I'm very, very happy. I mean, it is a great machine. There's no doubt. And hopefully this video will help somebody save theirs too that might end up in a similar situation that I did. I would like to have got the fan control working from the inverter board, but at some stage you just have to, be happy with what you have. If anyone does find out how, please let me know. Also, I mean, other conclusions, the heat pump and the inverter are very well made. I was impressed throughout with the quality of engineering on everything. Um, but the Tosot and Gree warranty does not mean much, really, and that's a supply chain issue. It's not to do with the engineering in it at all, and it's something totally outside of my control. And it's also something to consider when you're buying a Chinese device, no matter how well engineered it is. The warranty just may not stand up. No repair shop was willing to touch this job to fix it. And the other conclusion is AliExpress works, but it is slow. But they are, mostly honest dealers on it from what I can see, and the device does arrive eventually. So thanks for watching, and give a thumbs up if you liked it, and have a good day. Thank you.